So if we look at this, they've given us secant, negative square root of 30 over 3. They want cosine. For this one, all I have to do is flip it. So I can just put the 3 on top, the square root of 30 on bottom. With radicals, do you want to leave that 30 on bottom? We don't want to leave it on bottom, so to get it out of the denominator, we're going to multiply the top and bottom by the square root of 30, which is going to give us negative 3 square root of 30 over 30. Can I reduce?
Yes.
Yes, what can I reduce? The 3 and the 30. So my answer here is going to be negative square root of 30 over 10. So they've given us tangent and cosine. They want us just to use those basic identities to solve. One of the basic identities that we have is that tangent is sine over cosine. So if the tangent is sine over cosine, I can just replace it. The tangent, square root of 2 over 4, equals sine over cosine, which is negative 2 square root of 2 over 3. So I just rewrote this identity, filling in my tangent and my cosine. And then I'm just solving. I have what I'm trying to solve for divided by something. So I just multiply both sides by that. Multiply this side by it, they cancel out, and now I multiply this side by it. I have a negative 2 times, when I multiply square root of 2 times square root of 2, I get just 2. So negative 2 times 2 gives me a negative 4 on top. On the bottom, I'm multiplying 3 and 4, which gives me a 12 on the bottom. And then all I did was reduce it by 4. Divide top and bottom by 4, you get negative 1/3. So the Pythagorean identities is where we introduced sine squared plus cosine squared equals 1. They wrote it cosine squared plus sine, but it doesn't matter. It's addition. Tangent squared plus 1 equals secant squared. And then cotangent squared plus 1 equals cosecant squared. These are my Pythagorean identities. So now when I have these, I can solve a little bit differently than I did that other one. For the other one, without using Pythagorean identities, I had to use some type of quotient. But on these, if I have sine, I can go straight to solving for cosine because I can use a Pythagorean identity. In this case, they want us to find two things. So the first thing you want to do is figure out what you're trying to find. Here, they want us to find cosine. They want us to find tangent. So then we're going to look at what they have given us and the other information. This will tell us what quadrant we're in, all right? And so don't forget, when you're trying to figure out what quadrant you're in, you want to narrow it down using the information they've given you. The first piece that they have given us is that sine is negative. That narrows it down to 2 quadrants, all right? My sine is negative in the third quadrant, where they're both negative. Cosine and sine are negative. And in the fourth quadrant, where my cosine is positive, but my sine is negative. All right? So that tells me that first piece. I know I'm down to one of these two. Then they tell me that the cotangent is what? Positive or negative?
Positive.
The cotangent is negative, less than 0, okay? Here, if I were to put cosine over sine, which is what cotangent is, I would have a negative over a negative. So cotangent is what here? Negative over negative is a positive. So that means I must be in the fourth quadrant because they told me my cotangent is negative. That would be cosine over sine, positive over negative. Here my cotangent is negative, which means the quadrant that I am looking for is the fourth quadrant. That's the quadrant that I need right there. Once I've determined that, I'm going to use my Pythagorean identities. The first thing I'm looking at is they want me to solve for cosine. They have given me sine. Which Pythagorean identity am I going to use? So I'm going to use sine squared plus cosine squared equals 1. I'm going to fill in what I know. I know my sine. My sine is negative 1/3. So I'm going to say negative 1/3 squared plus cosine squared equals 1. When I square a fraction, I just square the top and bottom. And it's going to be positive because a negative times a negative is a positive. So this becomes 1/9 plus cosine squared equals 1. Subtract 1/9 from both sides. Cosine squared. 1 is just 9 over 9. So 9 over 9 minus 1 over 9 is 8 over 9. And then I am going to take the square root of both sides. Normally I would say positive and negative root, but I know I'm in the fourth quadrant. Is my cosine positive or negative in the fourth quadrant, my x value? Positive, so I only have to consider the positive root. 8 does not have a perfect root. Just simplify it with your factor tree. That's 2 squared root of 2. 9 does have a perfect root. That is 3. So my cosine here is 2 squared root of 2 over 3. I have solved for one piece of this. The next piece they want me to answer is what is the tangent? All right, what is the tangent? I have sine and I have cosine. The easiest way to get the tangent here is just do sine over cosine. All right, so when I'm solving for tangent, I could use another Pythagorean identity here, right? Secant squared. And I could take my cosine and flip it if I wanted to and solve for tangent that way. Once I have sine and cosine, I usually just put it in a fraction form. So my sine value here they gave me was negative 1/3. My cosine, I just solved for 2 squared root of 2 over 3. What's my method to solve this if I'm dividing fractions? Keep, change, flip. I'm going to keep that negative 1/3. I'm going to change it to multiplication. And I'm going to flip the denominator. So I'm going to say 3 over 2 square root of 2. When I am multiplying fractions, how can I reduce? I can reduce any top to any bottom. So what reduces here?
3.
The 3's reduce. So I can cancel those out. I get a tangent value of negative 1 times 1 is 1 on top. 1 times 2 squared root of 2 on bottom. What am I going to do here? Rationalize it. So I need to multiply the top and the bottom by square root of 2. On the top, I get just a square root of 2. On the bottom, I get 2 times this 2 that's created, so I get a 4. You cannot reduce that because one is inside the radical, one is outside of the radical. That is my answer for that second piece. All right, so we have cofunction and even and odd. All right, these are pretty straightforward. Cofunction, basically, it just moves you around a quadrant. So if I take the cosine and do 90 degrees or pi over 2 minus that angle, I'm going to have the sine value. And then same thing for sine. If I take the sine and do 90 degrees minus the angle. That's the same thing as the cosine of that angle. They're complementary to each other. Tangent and cotangent do the same. Secant and cosecant do the same. If it's in a different order, if it is the angle minus pi over 2, I need to negate it. I need to pull a negative out so that it meets the qualifications to use this particular identity. So that's where we get into the even and odd. For all of these, all of them change to positive and negative except for the cosine and the secant. If I take the sine of a negative angle, it's going to be the same thing as the negative sine. Same thing for cosecant, tangent, and cotangent. Cosine is the only one that doesn't change. And that's really because it just moves it over to the quadrant and that doesn't change it, x value. If it moves it down, its first and fourth quadrant is the same. So you can just think of how those quadrants move. So these are the identities that we usually get for sine and cosine. They've given us the sine of a negative angle. All right, the sine of a negative angle is negative 0.97. Negative 0.97. So we know that the sine of a negative angle is the negative sine. All right. So I can say that the sine then of the angle itself is positive 0.97 because they've already told us that. Then I'm going to use this identity here. The cosine of pi over 2 minus theta is the same thing as the sine, and that's what they want us to solve for. So I can say that the cosine then is this positive 0.97. All right, from there we went into simplifying trig expressions, all right? And so there's a couple ways to do it. The first way that we did it was changing everything to sine and cosine. So that's one of your strategies. It says rewrite using reciprocal or quotient identities, which means you're probably going to get everything in terms of sine or cosine. If you have anything that's squared, it's often easier to look for maybe some Pythagorean identities or to rewrite things using Pythagorean identities. If you have fractions, combine using common denominators, and then breaking the fractions apart. For this one here, we have secant, sine, and tangent. We're going to rewrite everything in terms of sine and cosine. So secant, in terms of sine and cosine, how would we write secant? 1 over the cosine. Sine is already in terms of sine and cosine, so we're going to leave that alone. And then that is being multiplied by tangent, which is just sine over cosine. So then I want to simplify this piece right here. I'm going to leave this one alone. Here I'm just multiplying sine times sine. What is sine times sine? So I have sine squared over cosine. Now here I already have common denominators. So when I already have common denominators, I can just combine that numerator. All right, so if I combine that numerator, I have 1 minus sine squared of theta over cosine of theta. On my Pythagorean identities, what is 1 minus sine squared? If you remember, my Pythagorean identity is sine squared plus cosine squared equals 1. I'm going to try to make that numerator out of this. So the way that I do that is just subtract that sine squared over. So cosine squared is the same thing as 1 minus sine squared. So I can replace this with what? Cosine squared. All right. And then I should be able to reduce 1 cosine out of the top and the bottom, which gives me just cosine. That is as simple as it gets. That is as simple as it gets. So go ahead and try number 2, using rewriting everything in terms of sine and cosine. So when I look at something like this, my first thought might be Pythagorean identities, which you could use. If you look at your Pythagorean identities, we have cotangent squared, which is cosecant squared minus 1. You could replace that and work it out here. You could rewrite it in terms of sine and cosine. So if you did sine and cosine, you'd have cosine squared over sine squared minus 1 over sine squared, and you can reduce it that way. So I'm going to show you a couple methods here, depending on which way you came across, like what you would do here. So if your first thought is Pythagorean identities, then you could look at this and you could say, well, my Pythagorean identity is cotangent squared plus 1 equals cosecant squared. All right. So I already have a cotangent squared. I could potentially just replace that one with my Pythagorean identity. So I could leave this cotangent squared alone, and I could subtract my cotangent squared plus 1. That's what cosecant squared is in my Pythagorean identities, right? And then if you distribute that negative through, you're going to get cotangent squared minus cotangent squared minus 1. These will cancel each other out. I just get negative 1. All right. If you immediately went to, well, let me change everything to sine and cosine, because that's what I'm more comfortable with. So then cotangent squared, well, that would be cosine squared over sine squared minus cosecant squared is 1 over sine squared. All right. I already have a common denominator. Cosine squared minus 1 over sine squared. All right, and if you remember your identity, sine squared plus cosine squared equals 1. So to get cosine squared minus 1, I would need to subtract the 1 over here and move the sine squared on this side. So cosine squared minus 1 is negative sine squared. And then on the top I have on the bottom I have positive sine squared. Those will cancel and I will get just negative 1. So you could have done that multiple ways. All right? You could have done it multiple ways. But when you see something squared, you need to probably look back and think Pythagorean identity. Even if you rewrite it, you're probably going to end up using a Pythagorean identity somewhere. So go ahead and try number 4. Before you do anything, you may want to think about rewriting this sine over cosine. So before I distribute anything, maybe think about what sine over cosine is, because the inside deals with tangent and cotangent. So go ahead and try number 4. Typically, people like proving a little bit better because they know where they're headed. It does say hint to work with the side that looks more complicated, right? And so most of the time, I will pick the side that I feel is the most complicated and then deal with that. So in number 1, I would probably start trying to simplify that left-hand side and go from there. You'll notice in number 1 that I have a cosecant, a cosine, and a sine. So when I have something like this, what I will do is I will write everything in terms of sine and cosine. Right now, Pythagorean doesn't really help me that much because I still have this cosecant kind of in my way. All right, so I'm going to rewrite this cosecant first. Cosecant is the same thing as 1 over sine. That's being multiplied by cosine squared. And then adding the sine. And I'm going to actually just leave this alone because I know I'm working towards cosecant, right? So we're just going to leave that cosecant alone. This is just cosine squared over sine. Plus my sine, well, my denominator here is just a 1. In order to simplify those fractions, what do you always have to have when you're simplifying fractions?
A common denominator.
Yeah, I need a common denominator, which is sine. So I'm going to multiply the top and bottom here by sine to get that common denominator. All right. So on the left, I have cosine squared over sine. And actually, I'm going to go ahead and combine those numerators. So that numerator is cosine squared. The second numerator is sine squared. All right. And then I am going to put my denominator of sine. What is cosine squared plus sine squared?
10, no.
It's just 1, right?
1 whole.
1 over sine. Is that true? It is. Yes. All right, so if we work this left side, I'm going to leave the right side alone. Sine squared is 1 minus cosine squared. All right, here is where you would split this, by the way. I have 2 numerators over a denominator. So I could say 1 over cosine minus cosine squared over cosine. Over here, one of these cancels. I can rewrite this. 1 over cosine is secant. And then minus cosine. Done. All right. If you worked the right-hand side, if I worked the right-hand side, I would rewrite that secant, right? Secant is 1 over cosine minus just cosine, and the denominator here is 1. I need a common denominator, so I need to multiply the top and bottom by that cosine. So in the numerator, I have 1 minus cosine squared. In the denominator, I have cosine. My Pythagorean identity tells me that 1 minus cosine squared is just sine squared. My denominator is cosine, which is what I was trying to get that side to look like. You could have done either side. It does not matter. Does not matter, whichever is easier for you to do. So here I'll leave the sine squared of alpha. I'm going to rewrite cosecant squared. Cosecant is the reciprocal of sine. And then leave this second sine squared alone. This is easy. When I multiply a number, anything by its reciprocal, I just get 1. Those will cancel. I just get a 1 minus sine squared. Pythagorean identity tells me that 1 minus sine squared is just cosine squared, which is what I was trying to get. All right, so go ahead and try number 4. So we saw that one of the things you can do with angles that are not necessarily part of the unit circle is you can split them up into two that are part of the unit circle and use your sum and difference identities to then solve using just your unit circle information. And so something like 105 is not on the unit circle, but 60 and 45 are. So I can rewrite this to be the sine of 60 degrees plus 45 degrees. And then I can look at my sum identity here, and I can rewrite that using that identity. The identity for the addition of two angles with sine is the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. So I'm just plugging it in to this sum identity because that's what I used here, 60 plus 45. And then my unit circle tells me that the sine of 60 is square root of 3 over 2. The cosine of 45 is square root of 2 over 2. The cosine of 60 is 1/2. And the sine of 45 is square root of 2 over 2. And then I'm just going to simplify it. They're going to have a common denominator. So square root of 3 times square root of 2 is the square root of 6. It's over 4. Plus 1 times the square root of 2 is the square root of 2, which is also over 4. And I am done. So go ahead and try number 2. Go ahead and try number 2 using your sum and difference identities. All right, so for this one here, I am simplifying expressions based on this.